Good morning. Hello to everyone. Welcome to SteelCon. Normally, I would be utterly hungover this morning, and I wasn't able to go out last night, so this is sort of broken from tradition. Bit of a shame, but oh well. Here we go. So, who am I? Rob Maslen. I'm currently a principal security consultant at Netitude. I spend most of my time either red teaming or developing tools. I spent most of my career, well, early days, in financial services, basically writing a lot of C++, C#, SQL, HTML, JavaScript, that sort of stuff. And 2013, I made the jump to InfoSec and never looked back, apart from the fact I still like spending a bit of time in Visual Studio now and again. I developed a few modules for my colleague Ben Turner's framework, PoshC2, mostly Sharp Socks and Port and Art Scanner last year. It's also part of Spicy Weasel, who won DEF CON CTF last year. Presented a workshop last year at SteelCon called Hit Client Destruction. And I'm also a massive fan of C# and LinkPad, which is kind of strange in the InfoSec world. There's a couple of blogs that I've helped to write, written, mainly last year. So what's the goal of today? It's basically to talk a little bit about some red teaming tradecraft. It's to show some of the problems that we face, how we overcome, and how we improve the solution over time. It's also to release our new PowerThIEf, which is our new IE post-exploitation framework, and also to make the case to some of you hardened IE users out there that it might be time to sort of start thinking about using another browser. So, red teaming, particularly if you follow InfoSec, Twitter or others, is a bit of a loaded term. Can mean quite a range of engagements. We look at it as essentially a simulated attack of an advanced adversary against a reasonably mature organization. It's threat intelligence led, but most importantly, it'll also have at least a primary and multiple secondary objectives. Now, my kind of experience of it, most of these sort of objectives generally are a web application or they're a thick client of some sort. They'll quite often hold vast amounts of business critical personal data. You'll sort of think of them as a critical sort of core application of a business. They're very much legacy. It's very, very rare to see anything that's been engineered or developed recently. They quite often have the ability to trade or transact. And also, if it's a web application, generally they'll be accessed by Internet Explorer. And it still seems to be the business browser of choice, unfortunately, which we'll get onto this later. So how do we gain access to these objectives? Well, we need credentials, right? So the methods we usually have of getting these is keylogging. I find with sort of the older thick client applications, quite often they'll have all the credentials to the database just stored in a file somewhere. Either, well, they could be in the registry or it could be in a config file. So you can generally find those and just bypass the application. Occasionally you'll get lucky and someone will just have an Excel spreadsheet or a Word doc with all their passwords, entitled passwords on the desktop. And if none of these work and the application has been opened and the user is logged into them, we can extract straight from memory. So cleaning up memory. One of the sort of goals of secure app development is to, well, one thing you should be doing is once you've allocated any memory that sort of has sensitive information in it, you should essentially clean up afterwards. Now, quite a lot of applications just don't do this. Partly if they're in a managed language, it's hard to do. Languages like Java or C#, you can't really deterministically destroy memory. Often too, you'll find that particularly sort of thinking of thick client, they realize that credentials are sensitive, so they'll be stored encrypted at rest. And so at runtime, the application will decrypt those, store them in memory, but they'll just be left around for convenience. So what do we do? Well, you can create a crash dump. Now, a crash dump essentially is not, you don't actually go and crash the application, or you can. They're designed to sort of aid you in debugging when you do have a crash. So it essentially contains memory and the current processor state. Now you can either analyze them on the machine once taken it. You can do this by just essentially scanning with regexes if you know what you're looking for. or you can take it out of the environment and load it into a debugger like WinDebug. So one method I use, a great tool from SysInternals, is ProcDump. And since I think it was Windows 10, you can now right-click within Task Manager and create a dump file. Now the issue is you're potentially taking sensitive data out of the client environment, which is not always good. You then have to manage that in a proper way, get rid of it afterwards. If you're on a slow beacon cycle, these files can be huge, and it can take quite a while to sort of get 1 gig out of the environment. It's also not particularly elegant. Other methods you've got is the Windows API has methods for being able to sort of, from one process, look at another process's memory space and actually go and read that via virtual query and read process memory. An example of one which we've used to good effect is Cisco AnyConnect. Now, this is a common VPN client that we sort of see on host. It's basically designed it's a couple of components. One is the userland GUI, which is VPN UI, and then you have a service which actually handles all of the actual VPNing. There's been a lot of privilege escalation bugs within the service in the past. But what's really handy is some clients, they'll do the right thing and use multi-factor token pins as essentially the password that will be used to connect to the VPN. Others will just use domain credentials. Now, Cisco, apart from being the world's leading supplier of hard-coded credentials, they also like to keep these in memory. And there's multiple bugs that you'll sort of find in Cisco's tracker where the clear text credentials just happen to be in RAM. Credit to those who found these, of course. Essentially, within the bug reports there, you can load up with HXD, which is a very, very good freeware hexadecimal editor. You can essentially attach to a process and just search through the memory space. And they have it in a really nice defined format. So you don't really need Mimikatz in this situation because this is just userland. This is actually running as the same user, and it just stores all your creds there. So you can go and find them quite easily. So can you do this sort of thing for browsers? Yeah, absolutely. You can do the same things, but there's a bit more of a challenge with this. In that most of them will have lots and lots of processes. Firefox has just moved to a bit more of a multi-process model, which has taken far too long. Chrome can have absolutely tons running at any point in time. You have to worry a bit more about taking sensitive data out, because if you do take 20 browser processors out, you will be taking a lot more data than you intended. And it's massively time consuming to sort of search through, particularly if you're not really sure exactly what you're looking for. So if we think about IE being our business browser of choice, is there a better way? And, this is what I started looking for. So absolutely. So to sort of, before we actually get into the tool, we need to go through COM, I'm afraid, which stands for Component Object Model. This is essentially the glue of what the tool uses. It's quite an old technology. It's been around for a very, very long time, but it's a core part of Windows and used all over the place. It sort of found a bit of a resurgence recently, particularly with sort of C++11 and moving to the more Metro-style Windows App Store. When I first started writing this talk, I started doing a bit of an introduction to COM, and it pretty much took up the whole talk. So what I recommend is this video from James Forshaw from Infiltrate last year, which is absolutely brilliant. It's COM in 60 seconds, which is a bit of a lie. It's actually much longer than that. COM will take you quite a bit of time to understand. But it's an absolutely excellent talk, well worth watching. Another good one is Sub-T and Matt Nelson's talk of Windows Archaeology from B-Sides Nashville last year. Matt Nelson's been doing a lot of stuff with lateral movement via DCOM, and he's got a lot of good blog posts. But this one in particular is quite a good talk to watch. So if you haven't watched them, the quick TLDR is that COM is an application binary interface. It's not a programming language. It enables components built with different languages to be able to talk to each other. It uses standard programming terms in slightly different ways, but essentially it consists of classes, which are basically just collections of interfaces. Uses the registry heavily, you'll probably have heard of a term of registering. That's normally just putting all of the details in the registry. From here, we can basically see OneDrive. At the first bit, there's what's known as the CLS ID. That's a GUID, which is globally unique identifier. And from down here, within here, we can see what's actually going to get run if you try and opening this up and running it is called activator. An interface, this is probably one of the more important concepts. It's essentially a contract between an object and any caller. It's defining what can be done, but it does not in any way define the implementation. It essentially doesn't matter what the implementation is. So it has a naming convention of I something. Every COM object has to support one called I unknown. So if we look here, we basically take the two doors. It doesn't really matter how they work, but what we're sort of saying is you can turn the handle. You don't really care about the implementation. The one on the left would probably support two, in that it would also support the door with key and unlock. So how do you know what interfaces an object will support? Well, you can just basically query them with the called query interface. So here, there's another concept as well called the Prog ID, and that's basically it here, xl.application. What we're essentially doing here with PowerShell is just activating XL. From here, I can set properties on it. I'm basically just setting a true or false on visible to hide and display it. And then call and get member. These are essentially all of the things that we can call. So what has actually happened when I did that new COM object? Using Process Monitor, which is excellent for learning about what's actually going on in Windows, another brilliant sysinternals tool, we can see that it does a lookup on xl.application. That in turn maps to a CLS ID, and that basically says, once you go in here, just go and open xl./automation. And then from there, looking within Process Explorer, we can basically see what's been run there. So there was an awesome technique, which was released in the Vault 7 dumps of last year. I'm not linking to it on purpose. Is basically a thing called junction folders and the class ID. So on the left-hand side here, we have a folder, which I've essentially converted to a link to control panel. And so you can take a folder and name it something dot, a squiggly bracket, and then a class ID. And then as soon as you navigate to that folder, it will do the same thing. It will essentially go to the registry, look everything up, look up what it needs to run, and then call it. So here, as soon as you navigate to that folder, it'll end up loading shell 32 DLL and launching the control panel. Now, I first learned about this from Beef on his Patreon channel, which was a talk on COM hijacking earlier in the year, which was absolutely brilliant. It's also in his DEF CON 25 slides, which is well worth a read. It's all about UAC, and other stuff. But what he essentially built within that was a tool so that you could quite easily create set your whole sort of registry structure up, so that you create your own folders with your own CLS IDs in order to navigate. Now, within the Vault 7 dumps and within Beefs, this was basically seen as a method of persistence. Now, I had a bit of an idea with this that it might be as useful as essentially a process migration tool. Because you're you're using Explorer to essentially, by navigating, you're using Explorer to load something. Now, if you sort of think about malware in particular, and also when we're conducting phishing campaigns, quite often the process that you're going to, once you've sort of sent in a Word document or something else, you're essentially your code's going to be executing within the context of Word or, Excel or something else. Now, for a lot of endpoint protection software, that's kind of suspicious if it starts making network connections. So what you want to try and do is to get into a process which is a bit more believable that it's having network connections. So in order to, try and see how this would work as a process migration tool, I was sort of thinking, what I want to be able to do is programmatically make Explorer navigate to one of these paths. And in order to do that, you sort of have to look at the Windows shell. So what's the Windows shell? It's basically any of the UI components that you deal with within Windows, be it the taskbar, the desktop, anything there, files, folders, that's the shell. Now the cool thing is about it is that you're able to sort of interact and customize it all via COM. Windows 8, quite controversially, got rid of the start menu, but classic shell, which is a product you can get for the internet, that brought it all back. It gives you a load of different customizations and other things that you can do. So thinking about this, I started looking into how this all works. The first class that you come across, the first object at least, is one called shell windows, which essentially represents all of the top level windows. Now, interestingly enough, there's a thing called, a property called item, which says it retrieves an Internet Explorer object that represents the shell window. And sort of thinking, hang on, why can I just activate a class and then get access to Internet Explorer? Seems a bit weird. It's all sort of in the registry as expected. Hang on, sorry, that's the class ID. And this is what it runs, which is, quite a complex string. And so taking it a little bit further, what do you get back when you look at that? Look at the items. The item is a collection, which means it's basically essentially an array of all of these. The interface that comes back when you look at it is one called iWeb Browser 2. Now this had a load of really interesting kind of members on it. Being the document, which relates to the document object model within HTML. It also had the location name, the menu bar, navigate, and quite a lot of others. Now, looking through all of the different methods, came across this one called navigate to, with this particularly interesting note in here, that said it was implemented for shell integration. Now, quick little side note here. Normally when Microsoft sort of changes a function or changes a method, quite often they'll give it an EX suffix. But within COM and interfaces, that they'll have a number that just increments. So in this case here, there is an iWeb Browser 2. There's also a 345, I think a 6. And it's the same with navigate, is that there is a standard navigate function which can't do shell integration, but they've added it and then they just add a 2 at the end. And so looking at the documentation for this particular method, we see that basically, it will either navigate to a URL or navigate to a file location, or it'll relate or navigate to a PIDL that represents a folder in the shell namespace. Now, I'm not going to go too much into what a PIDL, that's, if you watch James Forshaw's talk, he'll go right into that. So is there essentially a way to navigate to a class ID? Which is essentially what I wanted to find. So there's a really good method of getting around group policy file restrictions, which you can use in breakouts. And you can, within Explorer or whatever else, you can navigate to a shell location, such as in this case here, shell administrative tools. After a lot of Googling and a lot of research on some older sites, for the research on this, I sort of used quite heavily the Code Project, which was a sort of a programming site that's pre-Stack Overflow. So if you sort of look into kind of the Windows archaeology, that's a very, very good place to go. But what I found is, essentially you can go shell, 3 colons, squiggly bracket, stick your class ID in, and that'll navigate, it'll activate the object that you specify, and it runs. So putting this all together, here's some code in PowerShell, where it'll essentially, this is the CLS ID of shell windows. We basically tell it to get the type from the CLS ID. That will then create an instance of it. And we then call navigate to, and this is the CLS ID from control panel. Also worth noting here is 2048. That's it basically relates to nav open in a new tab. This comes from an object called browser nav constants. So you can open it in different ways, different tabs, different everything. If you're looking for further ideas on what payloads you might want to be able to run with this, Bohop's blog from a couple of days ago is actually really good. It ties a lot of COM payloads together. So here we go. This is basically it. Here we are. We're running this code, and in this case, control panel just launches. Sorry, I've got a drink. And interestingly enough, the process that it's ended up launching in is Explorer. So there's essentially no relation between kind of PowerShell where we've kicked this code off and eventually the process of where this gets run. That's Process Explorer, by the way, another excellent sysinternals tool. Now, as I ran this, I traced it with Process Monitor. And what we can see essentially is it's IE Explorer doing all the lookups from the class ID, everything else. So we've basically just got a way of controlling IE to go and launch essentially code of our choosing. So going back to the document object, which was essentially the DOM. What comes back there is an IE-HTML document 2. And what you can see is basically, if we look on the right-hand side, that's just an extract from the Chrome Document Explorer. It basically maps across. We've essentially got access to all of the DOM objects that we would expect. And we can read and write to these as well. That's just another view of the DOM. So in this case, this section of code, where we're doing pretty much exactly the same thing, in that we are sort of activating our shell Windows object again, creating the type of it, calling the activation there. Now in this case, we just, want to know the name of the type that document is, and then we're actually accessing the location.href, which is essentially part of the DOM. And then from there, we'll just call a get member on the document, and that'll list out all of the properties and methods that we have access to. That's not me supporting Sweden, by the way. I'll just... And there we go. So we can sort of see that page that was initially there. We can query. We've got the URL. We know what page is from PowerShell. And these are all of the members, or, properties that are essentially on the DOM there. You can kind of see that too, that it just keeps, the numbers keep incrementing on the interfaces. So something that's very important to remember, a lot of the blogs and a lot of my code in particular, and general writing that I've seen on this, makes the assumption that the first object within that item collection will be an Internet Explorer object. Now, what you've got to remember is the item can contain both Explorer and Internet Explorer. So all of those demos previously, I didn't have Explorer running, it was just Internet Explorer up. So you need to be able to have a way to essentially filter, which ones are IE, which ones are not. Fairly easy way to check is basically just to call .fullname, and you can just check, do a lowercase checker, just make sure it's Explorer, and do all your IE related stuff, or Explorer if you so desire. So everyone loves a XSS pop-up, and this here, similar kind of, we've got the same kind of code at the beginning. But what we're actually going to do this time is we're going to use .NET's really, really powerful reflection API to essentially look for the eval method. The reason for this is there's not enough type information for PowerShell to be able to work out that method's there. So we basically just have to go and find it. And from there, we can essentially invoke it. And what we're just going to call is a pretty lame, just, spawn an alert box. And there we go. So we've basically just been able to inject code into an IE process from another one. So talking about Matt Nelson again, he had really, really good stuff on lateral movement using DCOM, which is distributed COM. What you can actually tell when it does this get type is you can give an IP address, and then that will essentially go and activate that object on another machine somewhere else. So if you're looking at a really, really good way of easily deploying JavaScript crypto miners with an org, I think this is probably it. Not going to probably get too much money out of it, but. So, putting this all together, we have a method of enumerating all of the Internet Explorer windows on a machine. We can inject JavaScript into any running Internet Explorer window. We can navigate, we can edit the DOM, we can view the DOM, and we can also, via this junction folders and class ID, we can get Internet Explorer to essentially load any DLL of our choosing. Now, sort of thinking of all this functionality and the fact that, within a red team engagement, we're looking to target people who are probably using IE. This might make a really handy library. And so here it is. This is PowerThIEf. So essentially, when I first started looking at this, I've been a C# advocate for a very, very long time. Everyone's been going on about how cool PowerShell is. I've tried to avoid it. Finally came to the point where I probably should write something in it. As soon as I do that, everyone comes out saying, stop using PowerShell, just use C#. I wanted to make it compatible with tools such as PowerThIEf, which I'm a very big fan of, excellent piece of software. I also wanted to try and make it fileless and try not to touch disk. And in this case, it wasn't possible for various reasons, unfortunately. So I wanted it to be useful in situations that we face. So, for instance, targets using a password manager. This seems to be becoming a lot more common. Key logging is incredibly effective at getting credentials, but if people are using password managers and copying and pasting, then we're in a bit more of a problem. If we're trying to essentially harvest credentials and the user's logged into the application, they're probably not going to type them in. So what we want to be able to do is log them out of their application. Now, there are other ways of doing this, but they generally involve clearing all the cookies or clearing all the browser history, and I didn't want to do that. I wanted to be selectively targeting. I also face situations where you're sort of constantly screenshotting the target user. You can see that they've got IE open. You can see the target application, but it's in a background tab, and they just never seem to actually get to viewing it. So you can't actually see what's there. So what I'd like to be able to do is to be able to view what is in other tabs. And also too, I want to be able to sort of browse to sites within a background hidden tab from the user's machine, taking advantage essentially of cookies or the fact that they are, we need to go from their particular IP. So, PowerThIEf, which is the tool that has been created, which will be released on GitHub at some point today. The current functionality that's built into it is that you can dump HTML. You can either dump the whole lot from a page, or you can use a selector syntax to be able to target a particular name, an ID, or a tag type. It doesn't have jQuery selectors yet, but I'll get around to that at some point. You can use the migrate technique from junction folders to essentially get a DLL to launch in IE. Just make a quick note on there, actually. It's so Process Explorer, one of the tools I demonstrated earlier, that's come up with it'll now flag unsigned DLLs, particularly by highlighting them. And it seems to be there's quite a lot going on with application whitelisting and checking the signatures of DLLs. So in this point, yes, it works quite well, but using DLLs may not necessarily be the best option. I've seen stuff from Subt and others whereby, and if you look in that Bohop's blog post earlier, you can actually run script. So you could actually get this to build your own registry keys up and then just launch something in memory, script in memory. It'll also show or hide a browsing window. You can essentially hide them. You can hook logon forms and monitor for new windows in order to be able to essentially automatically credential harvest. You can invoke JS in any window that you want. You can list everything, list all the URLs that are currently being viewed. You can browse to any page that you want. I generally use this for logout. Or you can create a new background tab. In order to invoke anything, it's essentially you import the module, you then call invoke-PowerThIEf, and there's essentially an action parameter, and that should all use tab complete. So, in this example here, we have a page that has, say, an API secret, or it's got something in there that we need to obtain. And so here we go. We first import the module. We then call invoke-PowerThIEf /action list URLs. Now, what this will come back with is a list of all the URLs that are currently being viewed. It'll also give back a browser index. So whatever you call, apart from sort of list URLs, will generally be multicast to all of the different browser windows that you have open. And so if you want to refine whatever you do just down to one, like here, you just pass it a dash browser index with the ID that you've got from there. And so in this example too, we sort of see when it comes back to it, unfortunately can't pause GIFs or GIFs. I get a lot of grief for my strange pronunciation things. When this comes back, we can sort of see here that I passed a dash selector type of ID and a dash selector of API secret, and here that's returned back. So if that was a particular tag you're interested in or anything else, say you wanted to list all the div IDs in the page, you just go selector type tag and then selector of div, and then it'll come back. Okay, so in this case, I want to log Ben out of an application. Not saying I've successfully fished him or anything. That's the opposite would be true. And so in this case here, I basically just want to see what he's looking at, and I want to get him out of that 123 reg site, so then I can, essentially try and harvest some credentials. So in order to do this, I've just basically gone, found out what the logout URL is, pass it /navigate, and give it that. Once that fires, that's just going to trigger the navigation to the logout page and essentially clear his session. Once again, using the browser ID to so here we go. Now we want to do something serious. We want to basically, we want to process migrate into IE. And in order to do this, I've set up a PoshC2 server basically on the same machine. I've created a DLL payload. And okay, here we go. Come back to the first slide, first screen. Okay, so I've said basically action is exec payload. I've given the path to the payload, which is just a DLL. Something really important to note here is the way that IE is essentially architected, well, the later versions at least, is that it has a main process which is 64-bit, and then it has sub-processors which are essentially all the sandbox renderers and everything. They're all 32. So in this case, this will launch into the main process. So any payload that you use, any DLL, that essentially has to be 64-bit. So what this will do, goes in, it builds the whole registry structure for the CLS ID. It'll then launch it, waits 5 seconds, and then it'll clear all those registry structures out. And so I'll just go back to what we're seeing in the process monitor. Yeah, there's the shell coming in. There it is there. So what we're sort of seeing here is that, yeah, it's actually, it's Internet Explorer that's loading the DLL. Nothing else is realistically touching it, which is cool, and hopefully confuses a load of endpoint protection stuff. So what we'd also like to be able to do is essentially harvest credentials as they're being used. We want to be able to track any windows that are opened and closed. When a new window is open, we then like to essentially, and the page is loaded, we want to be able to scan, look for any logon forms or anything else that might be there. We then want to monitor when the user clicks submit or log on, and we want to be able to capture any credentials in transit. I've seen a form of this in Black Hat Python. It essentially rewrote the target form, the target of the form. For when it posted, it went somewhere else. I found in testing of other stuff that LastPass can essentially detect the changing of the target, so I wanted to basically avoid that kind of method. So is this possible? Absolutely. You can track the opening and closing of Explorer windows using the Windows registered and the Windows revoked events. When the window is opened, you can absolutely handle the DOM event, document complete. Because we can get access to the DOM, then we can essentially scan anything, all the, essentially the form or any input fields to look for ones that relate to logon. And then we can also hook the onSubmit form. So anything that gets posted, we can get back. And it sounds really easy, right? Well, it's not. So part of the problem is that the two events that we're interested in, Windows registered and Windows revoked, they don't actually exist on the shell Windows object. They exist on this object called dshell Windows events. So when you activate via, as we've done earlier, just by using the CLS ID, what you actually get is essentially a subset of all of the types. So here, what I've essentially tried to do is just do the activation, try and see what Windows registered is. It comes back as this kind of bound event, but PowerShell, it really isn't able to, there's not enough type information for it to be able to actually go then and register an event handler and anything else. So yeah, essentially shell Windows is basically just a subset. There's another concept in COM called the type library. These are essentially libraries of detailed type information. They contain information about all of the data types, the enums, structures, everything. They come in the form of like a type library. They can be embedded within a DLL, or they can be a DLL themselves. There's two type libraries that we need to load, which have loads of important information in them. One is IE frame. Can't find too much information about this one, to be honest. It appears to be an amalgamation of objects and types that are sort of contained within Browse URI, and also from this other library called Shell Document View. Shell Document View, as according to Jeff Chappell, in a real sense is just IE. That's essentially the IE library. If you use OLEview.net, which is an absolutely awesome tool as well, and just open up Shell Document View, you can find that this is where essentially this object exists and where these types are. So what do we have to do to get access to them? We need to basically do two things. We need to load IE frame into the process as a type library. We then need to generate a .NET wrapper around all of the types in Shell Document View in order to be able to give access to PowerShell. This would be horrible if you had to do it yourself, but thankfully there's a load of helper functions. The first one is in OLE Ort32 DLL, and this is called load type library EX. And that basically just takes, and see in the first parameter there, it takes a file. And it will also, within the second parameter, if you pass it a registry flag, it will actually go and register all of those types within the registry. In this case, we don't want to, so we basically pass it a none. And there's also really, really handy function within called convert type lib to assembly within .NET, which will basically take a type library and generate a wrapper around that, so all of those types can be used within .NET. When I said earlier that I didn't want to touch disk, this is one of the main reasons why we would be touching disk when this library loads, which is unfortunate, but there's no way really around this. So here we go. This one, I've essentially, so you can kind of see here, this is basically the code, can't see it now. But what this has actually done is use both of those functions to essentially load IE frame into the, loaded IE frame. It's then generated the wrapper around shell document view. And so now we can essentially register an event handler to there. Onto Windows registered and Windows revoked, so that any time any new window or tab is opened or closed, as we can see here, we get a message back, which is what we put in the alert handler, in the event handler. So we're all good. We can now get to these. We'll know because we have to, in order to be able to handle the DOM events, we have to use the iDispatch event handling pattern. Now this is horrible. This probably took most of the time in terms of writing this tool, and once again, this would probably be a talk in itself. So the two really good sites for information is basically, once again, going back to the code project, which predates Stack Overflow. This is a really, really good description on how to handle iDispatch events within C#, and that's what I kind of used in inspiration in doing it within this. So here we go. So we want to capture some creds. Another point too, sometimes, this is a bad example, but sometimes you'll sort of see within a query string, there'll be sensitive information like a session ID or whatever else. Being able to sort of view all of the URLs that are there, you can, locate them. So here we go. Just a form. I'm putting credentials in. I've set the hookup. Oh yeah, so we can basically see here. No, we can't. There we go. We captured the creds. So we go through. So we list URLs, loads everything up, sets all the types up. We then say we want to hook the login forms, and then that will just basically enumerate all of the windows that are currently there, and then it'll set all the event hooks and everything. And then once that's done, we'll get a little notification that creds have arrived. And then by typing action and creds, it dumps them all out. So what about LastPass and a password manager? Basically the same process. We want to hook the logon form. Here we go. Just pasting them in. And there we go. So we basically bypass password managers. So it currently supports IE 11, basically Windows 7 to 10, .NET 4, PowerShell 4 Plus. Mainly the restriction on the .NET version at the moment is because the C# code relies on a load of constructs which have come in later versions. It's not impossible to port it back, and I will be doing this at some point. And I also plan on writing it in as a pure C# module. So extra functionality that's planned in the future is I'd like to be able to screenshot, essentially do an offline render of any browser windows. I want to be able to steal cookies. I want to refactor the DOM event handling. It's quite hard to develop complex C# in PowerShell. It's not really a great method, so I, essentially would like to be able to create pure C# module and then have that load, and also bring in support for .NET 2 and 3.5. And as with everything, you start looking into something, and then you start getting messages saying we're going to deprecate IE at some point, yeah, kind of in July, actually. I agree with it, you should move away. So credentials are cool, but what we really want is cookies. So how do we get those? Well, you can just dump the process, or you can come to my next talk. So if you, look at Twitter or Node2 Labs for details. So where can you get this? It'll basically be up on GitHub at some point this afternoon. So any questions? Knew that was coming. Did you enjoy the GIFs or GIFs? Yes, use a different browser.